afternoon, ladies and gentlemen. My name is Sinya Podam. Today, I'm going to talk about green synthesis of silver nanoparticles using organic peel extract. Introduction: silver nanoparticle has currently attracted my attention because of its antimicrobial activity. It has been widely used in commercial products such as personal care, household, textiles, and medical products. Generally, the silver nanoparticles can be synthesized by several physical, chemical, and biological methods. Physical and chemical methods are usually costly, involve the utilization of toxic chemicals, require extensive labor and time, and generate secondary waste for the addition of chemical agents for precipitation and reduction in the process. Biological method has strong interests such as simple, safe, and environmental friendly. Homogenic peel is one of the ways from homogenic juice production. It has approximately 40% of the whole food and several bioactive compounds such as polyphenol, tannin, flavonoid, and anthocyanin. These compounds may possibly be responsible for the reduction of metal ions and being an efficient stabilization of synthesized silver nanoparticles. So the objective of this study is to synthesize and characterize silver nanoparticles from homogenic peel extract. Materials and methods. Preparation of peel extract. Peel of pomegranate were removed from house and were dried by freeze dry. The dried peel were ground into powder using a blender. The peel powder was extracted with the iron water at 100 degrees Celsius for 15 minutes. Peel extract was then the solution was filtered through a Rodman number 1 filter paper. The filter was centrifuged at 15,000 G for 20 minutes. Synthesis of silver nanoparticles using the pomegranate peel extract. Peel extract was adjusted pH into 3 different levels, including initial pH and initial pH plus or minus 1. So we will get using either 1 molar sodium hydroxide or 1 molar nitric acid. So we will get TPH2, TPH3, and TPH1. The peel extract was mixed with 10 millimolar silver nitrate solution. The solution was stirred at room temperature for 24 hours. The silver nanoparticles were collected using centrifugation at 12,000 G for 15 minutes. A pellet was tried with the iron water, then was dried by lyophilization. Characterization of preparation of silver nanoparticles, including energy deposit X-ray spectrometer, Fourier transform infrared spectroscopy, transmission electron microscopy, UV spectroscopy, and X-ray diffraction. Determination of phytochemical content in the food peel extract, including total phenolic content, total flavonoid, protein assay, and reducing sugar. Antibacterial activity. The antibacterial activity of prepared silver nanoparticles was tested against both gram-negative and gram-positive bacteria using the diffusion method. Nearly 0.1 ml each of the inoculum containing 10 to the 8 colony forming unit per milliliter of tested bacteria was spread uniformly on nutrient agar. Then the 20 microliters of peel extract, ampicillin, and silver nanoparticles was doctored on paper disc and was placed on nutrient agar plates. The plates were incubated at 37 degrees Celsius for 24 hours. The inhibition zone was evaluated by measuring the diameter of clear zone around paper disc. The result and discussion. Figure 1a show the effect of initial pH value of silver nanoparticle formation by UV with spectroscopy. The colors of the intensity of the peak depended on pH value. The result demonstrates that the color of reaction mixture changed from yellow to reddish brown. The characteristic of peak of silver nanoparticle due to the surface plasmon resonance was observed at around 400 to 500 nanometers. The absorption peak shifted to shorter wavelength with a rise of pH value, possible because of the decrease of size the silver nanoparticle. Figure 2b showed the figure 1b show XRD pattern of biosynthesized silver nanoparticle. The diffraction peak at 2 theta value has a good agreement with the standard diffraction pattern of JCPF number 040783. It is silver. It is noted that the diffraction peak corresponding to potential silver oxide can be observed from whereas dot mass. Figure 2 show FTIR spectrum. The absorption peak were assigned to OS stretching of alcohol presented in flavonoid and phenolic, CS stretching of alkane, C double bond O stretching of amine in protein, aromatic amine, and CN stretching of aliphatic. Moreover, the absorption pattern of silver nanoparticles and pomegranate peel was similar, suggesting that phytochemicals in peel extract are coated on the surface of silver nanoparticles. The figure 2b shows EDX analysis of prepared silver nanoparticles. The absorption peak corresponding to silver nanoparticle is detected at 3 electron volt due to surface plasmon resonance. The peak for carbon and copper were from the carbon-coated copper kit used for the TM sample preparation. Figure 3 shows TM image and size distribution analysis of prepared silver nanoparticles. The figure A to C present that the silver nanoparticles are irregular spherical in shape and are surrounded by a thin layer of organic material found in the extract. The average size of silver nanoparticles is the result suggests that the average size reduced with an increased pH which was consistent to the bullshit of the absorption peak in the UV spectrum. The quantity of phytochemical content in the pomegranate peel extract, including total phenolic content, total flavonoid content, reducing sugar, and protein assay, are shown in Table 1. The Table 2 shows the antibacterial activity of silver nanoparticles. synthesized at different pH values of the pH trap. All prepared silver nanoparticles had antibacterial capacity against tested bacterial pathogen. TPS1 were revealed against antibacterial activity among synthesized silver nanoparticles with an inhibition zone of 8.3 millimeter for Escherichia coli and 7.3 for Staphylococcus aureus. Conclusion: the average size of silver nanoparticles was in the range of 20 to 25 nanometers with irregular spherical in shape. The XRD pattern is crystalline in nature. All prepared silver nanoparticles show the antibacterial activity. The result from this work suggests that silver nanoparticles synthesized from this novel method have a good potential for usage in biomedical applications. Acknowledgement. Thanks Assistant Professor Dr. Niti Iomones, Dr. Philipon Thongpasu, and Dr. Vanida Wathanakarun for helpful technique assistance. The research was financially supported by Department of Biotechnology, Faculty of Engineering and Industrial Technology, Srinagar University. Thank you for your attention.
So thank you, Miss Minya. So it's an